Good afternoon, everyone. Welcome to this video lecture series, Time Response Analysis, Examples of Steady State Error, How to Find the Value of Kp, Kv and Ka. Okay, so today in this video lecture, again, let us find some few problems how to find the steady state error, okay, for various tests. Now in the previous video I have shown you how to determine the value of Kp, Kv and Ka, and how to find the type of system, or which for a given g of s, to which system it belongs. Okay, so now let us consider one problem here to find the steady state error for the various type of standard test inputs for a unity feedback system. Okay, so various in the sense, basically we have three signals. One is step, another is ramp, and then we have parabola. Okay, we have parabolic, or it can be parabolic. Okay, so these three are the step signals, or these three are the three inputs to the signals. Okay, now they have asked here is for a unity feedback system. Whenever the question it comes unity feedback, it means the value of h of s is equal to 1. Okay, so it means it is unity feedback, is unity feedback. Okay, now let us apply the other equations here, and for the given equation they have asked one time if it k is equal to 10 and other is k is equal to 200. Okay, so basically they have asked in one question the two solutions they have asked. Okay, so let us first consider the given equation. Okay, that is g of s into h of s is equal to k divided by s multiplied by s plus 5 multiplied by s plus 10. Okay, now the very first observation here you should make here is you should check if you have any s term here. Okay, if it is not available, it means it is a type 0. If it is only s, it is type 1. If it is s square, it is type 2. Now for the given problem, it is only s, it means it is type 1. It is type type 1 system. Okay, type 1 system. Okay, type 1 system. Now, so this is my first observation. Okay, first observation is I have obtained it is type 1 system. Now for the given system equation, you need to convert it into the standard format, that is in terms of 1 plus s. So let us do that first. So k will be as it is because we don't have any numerator term along with the k, so therefore keep k as it is. Then in the denominator, first keep s as it is and convert this s plus 5 into 1 plus t format. So how to do is take this 5 value. Okay, so multiply 5 or take 5 outside the bracket. So if you take outside the bracket, it becomes 1 plus s divided by 5. Okay, 1 plus s divided by 5. Then take 10 outside, it becomes 1 plus s divided by 10. Okay, now we got into the standard format. Now multiply this 5 and 10. So we get how much? It is 50. If you multiply 5 and 10, we get 50. Now just simply transfer this 50 into the numerator. It becomes k divided by 50. You can look here. It becomes k divided by 50. Okay, so if you transfer it into the numerator, it becomes k divided by 50. Okay, so we got the k divided by 50 whole divided by s will be as it is. Okay, then convert into the standard formula, that is 1 plus 1 divided by 5 is 0.2 into s into bracket 1 plus 1 divided by 10 is 0.1 s. So we got the new value of g of s into h of s. So what is the procedure we have followed here is, for the given system, okay, g of s we have converted into the standard value in terms of 1 plus t. Okay, and obtained the numerator and the denominator for a standard equation. After finding this, they have asked you to find the steady state error. That is, steady state error is represented by, okay, it is represented by ESS. Okay, so ESS they have asked you to calculate. Okay, so before calculating the steady state error, the another question which they have asked is you need to test for the various type of standards. Various type of standards is nothing but you should apply for step, ramp and parabola. Okay, so how to apply for each step here is first obtain all the values of Kp, Kv and Ka. Okay, for which type of system? For type 2 system. Okay, type 2 system. Obtain the values of Kp, Kv and Ka for type 2 system. Okay, you need to obtain the value. So how to obtain the value? Just simply write the formula, that is Kp is equal to limit s tends to 0 g of s into h of s, that is independent of s, limit s tends to 0. Simply you write this formula or the equation here, okay, and which is equal to infinity. Why it is equal to infinity? Okay, why? The question here is why it is equal to infinity? Because for a type 2 system, okay, for a type 2 system, the value of Kp is equal to how much? You can see a type 2 system. Okay, sorry, it is a type 1 system, right? For a type 1 system, the value of Kp is equal to infinity. Okay, so the value of A is equal to infinity. Okay, so here in the given problem, you can see it is infinity. Okay, similarly, go for applying it for Kv. So Kv is equal to limit s tends to 0, s into g of s into h of s, limit s tends to 0. Okay, write the whole equation as it is, but multiply s in the numerator. So it becomes s into k divided by 50, and you will get the value, that is k. Okay, that is k. And here the value of k is equal to k divided by 50. So this is your actual value of k. Okay, this is your k value. This is k value. So why it is k divided by 50? Because for type 1 system, okay, for type 1 system, you can find here the value of kv is equal to k. So therefore, according to the problem here, the value of k is nothing but k divided by 50. Okay. Similarly, go for finding the value of Ka. So what is the value of Ka? Limit s tends to 0, s square, g of s into h of s, limit s tends to 0. Write the whole formula here, okay, but simply multiply s square in the numerator, and that will be equal to 0. Why it is equal to 0? Because the value of Ka for type 1 system is equal to 0. Okay, so now we have obtained all the error coefficient for type 1 system. So first what we have done here is we have converted the g of s into the standard formula. We have obtained the value of k. Okay, we have solved for the different error coefficients for type 1 system. Okay, and the error coefficients for type 1 system are infinity, k divided by 50, and it is 0. Okay, then now you should apply for various standards of input. So let us consider the first input to the system here is step signal of magnitude 1. Okay, for magnitude 1. So what is the formula? What is the formula for the steady state error for step signal? Okay, here you can see in the table given that it is A divided by 1 plus K. Okay, the steady state error for type 1 system is 0. For type 0 it is A plus K. So therefore for unit step signal, if you are considering, then you should consider the value here. Okay, it is shown here is 0. Okay, but how you got 0 is first you should consider the formula. So which formula you should consider? This particular formula. You can consider the type 0 formula also. It is A divided by, but the value actually the answer is A divided by 1 plus Kp it is. Okay, 1 plus Kp, but the value of Kp what we have 16 here is it is infinity. So how to write? ESS is equal to 1 divided by 1 plus Kp. So that is 1 plus 1 divided by infinity. 1 divided by infinity is equal to 0. So therefore, how much we got? We got 0. And this should be verified with this table. So in this table, if you look, if you are using a step signal which is of type 1 system, okay, step signal type 1 system, what is the steady state error? It is 0. Okay. Similarly, if you have a ramp signal, if you are applying a ramp signal for type 1 system, it should be A divided by K. Okay. So what is A? If you do A divided by K here, you can see for A divided by K. Okay. So what we get the value? ESS is equal to A divided by K. But A is how much? A is 1. Why? Because A belongs to magnitude. So 1 divided by kV. Okay. So what is 1 divided by kV? It is 1 divided by kV is equal to 50 by K. So it becomes 50 divided by K. Reciprocal. 1 divided by 50 by K by 50 is equal to 50 by K. Okay. So it should be verified with respect to that particular value. Now, similarly, you can go for obtaining it for parabola. Okay. For parabola, again, if I consider magnitude is equal to 1, so you should again test with this particular table. If the signal is my parabola, which belongs to type 1 system, then it should be infinity, right? So let us check how this can be done. If you use this formula, ESS is equal to 1 divided by kV. Okay, 1 divided by Ka. So it is 1 divided by, what is the value of Ka here? Ka value is equal to 0. So 1 divided by 0 is equal to infinity. So therefore, we obtained the 3 different steady state errors for 3 different magnitudes. Now, the another question which they have asked here is, if the value K is equal to 10 is how much? If you take K is equal to 200, then what should be the value? Okay, if you take K is equal to 10 here, okay, then the steady state error is equal to 5. For ramp it is, for ramp, okay, because for other it is not considered, because for step the steady state error is 0. We cannot divide or we cannot even multiply the value of K here, so therefore it is completely 0. Same thing cannot be applied for parabola. Why? Because it is infinity. Infinity multiplied by K or divided by K, again it becomes infinity. But it is only applicable, those two values are K are only applicable for the ramp, because for ramp we got the K divided by 50. Okay. Now first you put K is equal to 10. If you put K is equal to 10, you will get 5. If you put K is equal to 200, that is 50 divided by 200 is equal to 2.0.25. Therefore, with this particular problem here, we have obtained the value of K, standard value of K, that is K divided by 50. Okay. And then the type of system is type 2 system, and we have tested it for all the 3 signal, that is for ramp, for step signal it is infinite, for it is 0, for parabola it is infinity, but for ramp it is K divided by, it is 50 divided by K. And for that 50 divided by K, we have tested with these two numbers. With these two numbers, the steady state error for the ramp is, one is 5, another is 0.5 respectively. Okay. With this solutions, I conclude this problem. Okay. Thank you.